Lab. This is part 2 of the Blackface Fender Deluxe Reverb repair. This is a Mojotone kit. In part 1 I showed the issues and some of the things that needed to be corrected. In part 2 we're going to correct it and then test it. Hopefully it turns out well. Here we go. Alright, I've got the Deluxe Reverb amp fully functional. Reverb and tremolo were out, and that just turned out to be a minor wiring issue. What's going on now is noise. There's quite a bit of it. So I'm going to install this brass ground plate behind the controls like Fender did, and we're going to clean up this wiring, make it look neater, and add some shielded cable. Then I'll retest. Alright, I've got the brass plate sitting behind the front panel. Now I need to pull her tight, get it marked and drilled, and then we'll swing these pots back into position. I'm also going to add some more shielded cable. I've got the input jacks completed, but the volume pots also need the shielded cable, and of course these ground runners now will swing down to the brass plate. There's the new brass ground plate installed behind the controls. Next step, we're going to clean up the wiring, swing all those grounds off the back of the pots and take them down to the plate where they belong. Alright, now that I have the grounds all secured to the plate, I want to give this thing a quick test before I move forward with a wire replacement. So we're going into the dummy head with the audio generator, and here's the scope. Before, I had quite the noise floor down here. That is much better. So the grounds helped immensely. Good deal. Alright, next thing we're going to do is replace all this filament wiring with a proper gauge wire. I'm going to put a new terminal board down here for ground distribution, and we're going to add the current shunts so we can see how much current is running through the output tubes. If you watch some of my past videos, you'll see I'm not a fan of landing the high current filament lines up here on the lamp assembly. I like to put that on a separate terminal board and run simply 22 gauge over to the lamp. So I'm getting ready to do that, and I spotted something I have to show you guys before I take it apart and lose the opportunity. Look right down there. See that wire? Not even soldered to the lamp assembly. So since that's the main 6-volt feed, that means all the tubes we're probably seeing some intermittent connection on the filaments. Good thing we're going through this amp. A lot of bad connections to be taken care of. Filament circuits are totally disconnected at this point. I've removed the original terminal board and I'm going to install a new one. But you can see I've roughed up the chassis because this one will be soldered direct to ensure we have a really secure ground connection. Here's our progress report on the filament circuit. I have the new terminal board landed. There's the 100 ohm balancing resistors. 22 gauge wire now going to the lamp. This was one of the original feeds. I shortened it up. I have not went down the line yet. You see these two resistors. These are 1 ohm resistors, and the black wires coming off those go to pin 8 of each output tube. So this will allow you to monitor the current through the tubes when you set your bias. So let's go ahead and fire it up and check that bias, and then I'll continue on with the filament circuit. So here we go. We're going to check the bias. In this case, it's the current flowing through the output tubes. These are 6v6s, so I would hope to see somewhere around 20 to 25 milliamps of idle current. So without these little 1 ohm resistors, there's really no way to actually measure that current. You have to calculate it, and that's why I do this. It makes it simple. You guys know I like things simple. Since it's a 1 ohm resistor, it'll be proportional. So if you see 10 millivolts on the meter, that's 10 milliamps through the tube. Alright, so I'm going to grab this guy right here. You see we had nothing because standby is not turned on at this point. So let's turn on the high voltage. So look at there. Got 56 milliamps Obviously can turn that down if the negative bias will let me. Oh yeah, there we go. It was actually all the way up, guys, which is not a good thing. 60 milliamps flowing through a 6v6 is like 3 times the current that it should be. Okay, so there's one tube, here's the other tube. You would hope to see these are balanced. So if you bought a matched pair of tubes, you would hope that they'd be within a millivolt of each other, and these are. These are actually a pretty good set of tubes. Alright, we have the bias set now, so we're not going to flame out the output tubes. Next, I need to go down the line and pull out that gigantic filament wiring, reduce it down to 22 gauge for the preamp tubes. The other thing that I don't like here, this is our AC feed, okay? That's 120 AC black and white, you'd expect that, but they also use black and white for the filament leads. Kind of confusing. Amp is off, unplugged, so at this point I'm just going to carve out this old black and white filament line. I don't plan on reusing it anyway. And we'll come in with a new feed with the proper color code, make it look good. So before I rewire it, let's just scan the connections on these tube sockets. Now before, with the gigantic filament wires in here, I wasn't even able to see these pins. There's definitely some cleanup work that we can do and make this thing look really nice, and also easier for the next guy that has to do maintenance. I've got all the new filament wiring installed. I use this nice 20 gauge Teflon jacket green. You can see it really improves the looks of the amp, plus now you can actually see the sockets. I did have some issues with the old original wiring. If you take a look at this, you'll see it's kind of a coated color, but it's white underneath, and when you solder to this stuff it likes to retract, and of course it burns easily. It's not my work, okay? The other thing I did, of course, was install the ground plate, and all the ground runners now go to that. And as I said before, I installed the current sensing resistors. I have the bias set on the amp. It's ready to give a shot. Yeah, well,
sounds pretty good, but it's still...
It looks like the real thing, but it's not the real thing.
It isn't.
Right, that's the way it is, yeah. Alright everybody, so I have Tony over here. He's shaking down the MojoTone Deluxe Reverb amp that I was repairing. This is the one, it was pretty much unusable. It was a noisy wreck. The wiring internally was terrible, and I've gutted that out. So this is the maiden voyage. So I had to have the master. So it's usable.
Yeah, sounds pretty good.
Yeah. Yeah. It's better than what the guy walked in with.
Yeah, well, it was a total wreck when it came in. It's working good now. I mean, it's relatively, it's up, it's as good as it's going to be.
Yeah, exactly.
It sounds like a Fender. Not the best Fender I ever heard, not the worst.
Would you say you think there's an element of depth that it might be missing?
So, I can't put my finger on it, really. Something's not quite as good as I'd like to hear it.
We think that might be like quality of output transformers, possibly. It's hard to say.
Yeah, that'd be my first guess. From what I've learned from you, Terry, I would say it might be the transformers aren't as good as those of olden days.
Yeah.
Maybe the tubes.
your JJs.
Yeah, well, that's part of it right there, I can tell you.
Yep.
And then, it doesn't, you know, these clone amps, they emulate, they don't duplicate.
Hey, good. That's good. I like that. I'm going to use that. All right, man.
It's,
What it
it's
is.
working good though. It's the noise threshold is acceptable and the tone is acceptable and it's working properly. I'm sure it's going to have a good long life now the way it is, but
Yeah. Yep.
it is what it is.
Sure, man. Mission accomplished.
Mission accomplished.
Great.
Good job.